Hello students, in the last class we discussed about the phosphorus halides, that is PCl3 and the PCl5. In this class we can study about the oxoacids of the phosphorus. Oxoacids of phosphorus, this is very important for both your board exam as well as for your competitive exam. You have to practice the structures and you have to practice the names of the oxoacids. For example, first one, hypophosphorus acid. Hypophosphorus acid. Hypophosphorus acid formula is H3PO2. The oxidation state of phosphorus is +1. Oxidation state of phosphorus is +1. That hypophosphorus acid, to write the structure of hypophosphorus acid, here you have to consider some points. That hypophosphorus acid contains one POH bond. You must write one POH bond, two pH bonds, and one PO bond. By using this one, you can write the structure. To write the structure of hypophosphorus acid, you must write one PO bond, two pH bonds, one POH bond. And you can also consider the basicity. The basicity value given by the number of POH bonds. The number of POH bonds gives the basicity value. Here, one POH in basicity is 1. This is about the hypophosphorus acid. Second one is orthophosphorus acid. Orthophosphorus acid, H3PO3. Oxidation state is +3. It has two POH bonds, one pH bond, and one PO bond. Then can you guess the basicity? Basicity of this compound is 2. Why basicity of orthophosphorus acid is 2 means because it contains 2 POH bonds. This is about the orthophosphorus acid. Then pyrophosphorus acid. Pyrophosphorus acid formula is H4P2O5. In H4P2O5, again oxidation state of phosphorus is +3. It contains 2 POH bonds. To write the structure, you have to mention 2 POH bond, 2 PO bonds, and 1 PP bond. It also contains phosphorus bond, 1 PP bond. Then again basicity value is because of 2 POH bonds. Next one is hypophosphoric acid. Hypophosphoric acid formula is H4P2O6. Oxidation state is +4. Already in first year you know that how to calculate the oxidation states. +4. It has 4 POH bonds, 2 pH bonds, and 1 PO bond. Hence hypophosphoric acid basicity value is 4. Then orthophosphoric acid. Formula is H3PO PO4. Then oxidation state is of +5. It contains 3 POH bonds, 1 PO bond, hence basicity value is 3. Then pyrophosphoric acid, H4P2O7, oxidation state is +5, as 4 POH bonds, 2 PO bonds and 1 POP bond. Then basicity value, it is of 4. Then one more, metaphosphoric acid, HPO3N. This is the formula. Oxidation state here is +5, contains 3 POH bonds, 3 POP bonds, and 3 PO bonds. Then basicity value, it is equal to 3. This is about the oxoacids. You have to practice the formulas, and you have to remember the number of bonds, what type of the bonds present. Then easily you can write the structures. If you know the number of POH bonds, then you can write the basicity value. Then in our syllabus, some examples are there. Next you can study the examples. Next one is the structure of some oxoacids of the phosphorus. In our syllabus only 3 examples, 3 oxoacids of phosphorus structures. First one is orthophosphoric acid. That orthophosphoric acid formula is H3PO4. By using that one, you can write the structure. That is, it has 1 PO bond, and 3 OH bonds. All have tetrahedral structures. 3 OH bonds. Hence, by using this structure, basicity value is 3 because of 3 POH bonds. Then orthophosphorus acid. That orthophosphorus acid formula is H3PO3. Structure is, it has 1 PO bond and 1 PH bond and 2 POH bonds. All have the tetrahedral structures. This is the structure. By using that one, basicity value is 2. Then one more is the hypophosphorus acid. Formula is H3PO2. Structure is, it has 1 PO bond, 2 pH bonds, 1 POH bond. Then the basicity value is 1. You practice these 3 structures for your board exam. In the board exam, they can ask only these 3 structures: orthophosphoric acid, orthophosphorus acid, hypophosphorus acid. By using this one, you can write the basicity value. In addition to that one, in NCERT book, they considered 3 more exam structures. Next, you can practice for your competitive exam. In competitive exam, this is very important one. Next, you consider other three more structure. For your board exam, you practice these three only. Next, one more is an pyrophosphoric acid. Pyrophosphoric acid. Pyrophosphoric acid. Formula is H4P2O7. H4P2O7. The structure is given by, it has one POP bond. It has one POP bond. Then PO, two PO bonds. Then 4 POH. For each phosphorus, 2 OH bonds. This is the pyrophosphoric acid. Then basicity value for this one is 4. This is about the pyrophosphoric acid. Then you can consider cyclometaphosphoric acid. Trimetaphosphoric acid. Trimetaphosphoric acid. Trimetaphosphoric acid, that is of HPO3N. That N is taken as N3. N value is taken as N3. Then the cyclotrimetaphosphoric acid structure is, that is POP, then OP, then OP, then each phosphorus one POH and PO bond. One PO and one POH bond. This is the cyclotrimetaphosphoric acid. Then one more is an polymetaphosphoric acid. Polymetaphosphoric acid. Polymetaphosphoric acid, that is of HPO3N. Then the structure is given by PO, here continuation, then OH, then O, POP, then it has OH, double bond OH, then OP, double bond OH, O continuation. This is the polymetaphosphoric acid structure. These three structures are also included in the NCERT book. But in your board exam, they will not ask these three structures. They ask only orthophosphoric acid, orthophosphorus acid, hypophosphorus acid. Then by using these structures, you can consider some characters of these oxoacids of the phosphorus. In that characters, in all oxoacids, the phosphorus atom is sp3 hybridase. In all the oxoacids, phosphorus is sp3 hybridase and has a tetrahedral structure. All the oxoacids have the tetrahedral structure. These are first characteristics. The second one is, these oxoacids, they must contain one PO bond. And at least one POH bond also. One PO and one POH bond. Then in oxoacids of phosphorus, in which phosphorus has a lower oxidation state. If phosphorus atom has lower oxidation state, generally less than 5. They contains one PO. They contain one PO and one POH. They contain one PO and one POH. They contain either PP bond, either PP bond or pH bond. They contain either pH, PP or pH bond, but not both. This is the condition. In oxoacids of phosphorus in the lower oxidation state, lower, that is less than 5, in addition to PO and POH. They must contain one PO and one POH bond. In addition to PO and POH, they contain either one PP or pH, but not the both. Then next point is the pH bonds. pH bonds, they are not ionizable. They not decides the basicity. pH bonds are not ionizable to give the H plus ion. They are not ionizable. Only the hydrogen atoms, which are bonded to oxygen, in POH are ionizable. Which hydrogen atoms are ionizable means the hydrogen atoms which are bonded to oxygen atom. Those are ionizable. That is POH. POH bonds hydrogen atoms are ionizable, but not pH bond hydrogen atoms. And these number of POH bonds are responsible for the basicity or acidic nature. Basicity value is given by only number of POH bonds. Only POH bonds are ionizable, but not the pH bonds. You consider H3PO3 and H3PO4. H3PO3 and H3PO4. H3PO3 that contains two POH bonds. H3PO4 contains 3 POH bonds. Hence, basicity for H3PO3 is 2. Here it is 3. Basicity value is 3. Therefore, this is called H3PO3 is called dibasic acid. If basicity is 2, then it is called dibasic. This is called H3PO4 is called tribasic acid. Basicity 3, then it is called tribasic acids. Then next point is the oxoacids, in which the +3 oxidation state of phosphorus, +3 oxidation state of the phosphorus, they undergo disproportionation. They undergo disproportionate to higher and lower oxidation state. In oxoacids, +3 oxidation state. If phosphorus is present in the +3 oxidation state, they disproportionate into higher and lower oxidation state. For example, you take H3PO3. In H3PO3, phosphorus atom is in a +3 oxidation state. It disproportionate into PH3 and H3PO4. In PH3, phosphorus atom is in the -3. In H3PO4, it is in the +5. It is in the +5 oxidation state. Then one more point is the oxoacids which contains pH bonds. The oxoacids which contain pH bonds, they have strong reducing property. Is the one more point. Oxoacids which contains pH bond, they have strong reducing property. For example, hypophosphorous acid hypophosphorus acid H3PO2. Hypophosphorus acid that reduces the hypophosphorus acid which contains two pH bonds, and reduce silver nitrate to silver, that reduces silver nitrate into silver, that is AgNO3 plus H2O plus hypophosphorus acid H3PO2, that reduce silver nitrate into silver, Ag, then HNO3 and H3PO4. To balance this one, 4AgNO3, 2H2O, then 4Ag, 4HNO3 and H3PO4. That is the acids which contains pH bonds. Oxoacids which contains pH bond, they are strong reducing property. Example for that one is hypophosphorus acid has 2 pH bond, hence it reduces silver nitrate solution into metallic silver. This is about some characters of the oxoacids of the phosphorus. These characters, they are also important one. That is, in this point, the oxoacids in +3 oxidation state of phosphorus disproportionate to higher and lower oxidation state. In some cases, then this H3PO3 is heated. What happens when H3PO3 is heated means you can write this one only. It is disproportionate. Into pH3 and H3PO4. Remember this one also. This is about the characters. The next class is about the 15th group element. 15th group elements is completed. From next class onwards, you can continue the 16th group elements.